I want to explain here what's understood to be factorizing in mathematics. Let's just look at two numbers, say 28 and 98. All numbers in mathematics can be expressed as product of prime numbers, powers of prime numbers. So there is a technique to reduce any number to its powers of prime. So I'm going to do that, and then I'm going to show you what that leads to and what sort of valuable information that will lead. So if you wanted to express 28 as powers of prime numbers, now prime numbers, a prime number is any number that only has itself and 1 as factors. So for that reason, the smallest prime number is 2, because it has 2 factors, and they are itself, which is 2, and 1. The next prime number is 3. The only 2 factors of 3 are 3 and 1. We don't have 1 because they're not 2 different factors. 1 and 1 is the same number, so it only has 1 factor. So a prime number has 2 factors, itself and 1. The next one after that would be 5. 6 is not prime because it's got more than 2 factors. 7 is prime because it's 7 and 1. 8 is not prime, it's got more than 2 factors. 9 has got more than 2 factors, and then 11, 13, 17, etc. So they are the prime numbers. So if we're going to reduce, say, 28, now I like to draw a vertical line, and we look for the smallest prime number that goes into 28 evenly with no remainder. So we scan through here and we say, okay, 2 will go into 28, and we divide 2 into 2, goes once, 2 into 8 goes 4. And we look at 14 and we say, what's the smallest prime number that goes into 14? Well, once again, 2. 2 into 14 goes 7. We keep on going down until we get 1 down here. So 2 won't go into 7, 3 won't go into 7 with no remainder, 5 won't, but 7 will. So 7 into 7 once. Now at that stage we stop and we say that 28 equals, and we just run down this vertical column here, and they should be in ascending order if you've always gone smallest first. So it'll be 2, how many 2's have we got? 2 of these, so 2 to the power of 2 times 7. So we have reduced 28 to powers of prime numbers. 98, 2, 49 times, 2 into 98 goes 49. 2 won't go into 49 because it's an odd number, so 3 won't go into 49, 5 won't, 7 will. 7 into 49 goes 7, and 7 into 7 goes once. So 98 equals, there's only 1, 2 to the power of 1, just 2, times 7 to the power of 2. All right, so if we wanted the highest common factor, now the highest common factor, the way we write that, HCF stands for highest common factor. And just think about what those words mean. The highest common factor. Now a factor is a number that will divide evenly. Common means it's going to go into both 28 and 98, and the highest means we want the biggest factor, the biggest number that'll go into 28 and 98 evenly. You can already see that both of these are even, so 2 is a factor of both 28 and 98, but not necessarily the largest. So the highest common factor of 28 and 98, instead of writing that out all in English, we write it like that. The HCF of, in capitals there, of the two numbers separated by comma and brackets equals. Now what we do is we look at the breakdown of prime numbers and we say, right, there's some 2's in both. Now what is the highest power that's common to both? Well, we've got a 2 to the 2 and a 2 to the 1. So the highest power that's common is just 2 to the 1. We don't have 2 to the 2's here. So it'll be just 2. Then we go to the next one. We say, right, we've got some 7's going on. What's the highest power of 7 that is common to both? And it's just 7. And just scanning through, they are the only two factors. In this case, they're the only two ones we need to worry about. So the highest common factor of 28 and 98 is 2 times 7, which is just equal to 14. The lowest common multiple is abbreviated as LCM. Now if we want the lowest common multiple, we want a multiple of a number is just a bigger number that the smaller number will go into. So a lowest common multiple is the smallest number that both 28 and 98 divide into evenly. So 28 will go into itself, but 98 won't go into 28. If you look at 98, well, 28 doesn't go into 98, but 98 goes into itself. But what is the smallest number? So it's going to be bigger than the largest number, at least as big as the largest number. Now to work out the lowest common multiple, so we're looking for the smallest number that both 28 and 98 go into evenly. The way to do that is to write down one of the factors, one of the prime factorizations. Now, usually you write down the largest one, and we've got 2 times 7 squared. We haven't finished yet. So we've written down one, and we say, okay, have we got, looking at this here, 2 times 7 squared, go to the other one, have we got a 2 squared there? No, we haven't. So we've got to make that into 2 squared. Go to the other one here. So 28 is 2 squared times 7. Have we got 7 covered here? Yes, we have. We've got more than 7 to the power 1. We've got 7 to the power 2. So that is going to be the LCM. And in fact, that will be equal to, as you multiply it out, we've got 4 times 49, which is 196. So 196 will be the smallest number that both 28 and 98 go into. 28 goes into that, how many times? 7 times? 7 times 28, and 98 goes into that twice. How do we use the highest common factor and the lowest common multiple? If we had, say, 28 over 98 and you had that as a fraction and you were trying to cancel it down and you were looking for the largest number that goes in, now that's the highest common factor. So if you were trying to cancel this down, we would divide by the highest common factor to get straight to the fraction in its lowest form. So if we divide both of these by 14, 14 into 28 goes 2, and 14 into 98 goes 7. So just dividing by the HCF, which is 14, divide by 14, and we'll get 2 over 7. When do we use the LCM? Say you had a fraction, say you had 5 over 28 plus 11 over 98. And you were trying to find out what is the smallest, the lowest common multiple, because that's what we'd have to make them both into to be able to add the fractions. Now we've said that 196, so we'd have to make both of these into 196. So it'll be 5 over 28. Now we've already seen that we've got to multiply that by 7 to get to 196, so we multiply that by 7, plus 11 over 98. What have we got to multiply that by to get to 196? 2 times 2. Then you've got 196, and you'll be able to add your fractions, 35 plus 22, and so on. So you've got 57 over 196. So the LCM is used when we are adding fractions. The HCF is when we're trying to cancel fractions down. Prime factorization is worthwhile remembering because it's going to help us with some of the algebraic stuff we're about to do.